Okay, now how do we use ratios and proportions to solve problems? Well, let's say if we know that it costs $7 for 8 apples. Now, what if you wanted to buy 20 apples? Okay, I'm going to set these up as equal ratios or as a proportion. I said 20 apples, where am I going to put it? I like to put this on the side so I don't get confused. I'm going to keep my cost on the top, I'll keep my apples on the bottom. So if 8 apples is $7, where am I going to put 20 apples? I'm going to put that in the denominator, just as I had them down here. And how much does it cost? I don't know. I'm going to use a C. As you know, you can use any letter you want. I'm going to use C for cost. Maybe it's C for cash. Sometimes you can see, if I would have said 16 apples, it would have been easy, right? 8 times 2 is 16. 7 times 2, $14. But we're not dealing with something that's nice and easy. So we have to figure out how much is this going to cost us. Well, the only time in mathematics that I would suggest doing what they call cross-multiplying is when you're trying to solve a proportion. And it's a foolproof way of solving proportions. So what I'm going to do is I'm going to cross-multiply and say, okay, 8 times C is equal to 7 times 20. 7 times 20 is 140. Now I'm trying to solve for cost, so I want to get the C by itself. Right now I'm multiplying by 8, so I'm going to do the opposite of that. I'm going to divide by 8. That will get C by itself. Because remember, what is 8 over 8? It's just 1, or 1 times C, just C. Now since I divided this side of the equal sign by 8, I have to divide this side of the equal sign by 8. It keeps it equal. Okay, so let's do the work over here. 140 divided by 8. 1 time, and that's an 8. 14 minus 8 is 6. 67 times, right? 7 times 8 is 56. Well, 56. Subtract that off, I have a 4. I better add a 0 to that. In fact, since I'm dealing with money, why don't I just add 2 zeros? Bring down this 0, and 8 goes into 45 times. Evenly with no remainder, but there's still that other 0 there. I'll go ahead. So that means that the cost of 20 apples is going to be $17.50. Some of them will be more complex than this, some of them will be easier than this, but the same process, this cross multiplication, will always solve for an unknown ratio in proportion. Okay? So let's look at some complex proportions. What's a complex proportion? Well, if you remember the complex fractions we were looking at and the complex fractional division problems, it's the exact same thing. So if I have a fraction that, let's say I have 1/2 over 2/3, and that is equal to let's say 9 over x. Well, again, this is complex because it is a fraction on top of a fraction, which, as we know, is just a division problem. But we can solve it this way also. We're going to go ahead and, just like before, we will cross multiply. So I'll go ahead and say 1/2 times x is equal to 9 times 2/3, or 2/3 times 9. It doesn't matter which order you want to do this. First thing I'm going to do is I'm going to convert the 9 to a fraction. 2/3 times 9 over 1 is equal to 1/2 x. It's 18/3 equals 1/2 x. 18 divided by 3 is just 6. 6 equals 1/2 x. And now, how do I get rid of a fraction? I multiply by the reciprocal. So if I'm trying, the opposite of multiplying by 1/2 is dividing by 1/2, which ends up being multiplying by the reciprocal, right? So I'm going to multiply by 2 over 1. That gives me 2 over 2, or just 1x. But when I multiply this side by 2, find out that x equals 12. So as complex as this looked, all we're doing is the exact same thing. We're going to cross multiply. We know how to multiply fractions. We know how to divide by fractions. And we find out that x is equal to 6. Simple enough. I'm going to stop right now because we are getting over 5 minutes. But we have one last thing to talk about, and that's the nutritional application. So when you're ready, just click on that video.